In this video, we will try to create a pattern, a geometric pattern that's driven by an image. And I will go through step by step all the process that it takes to create this. Okay, so let's start a new file. And first we need to create a surface in Rhino. It's a simple rectangular surface, nothing fancy, 48 inches by 36 inches. I will uncheck show ISO curve so surface appears a little cleaner. Now let's first bring the geometry into Rhino, into Grasshopper. Under geometry, params, geometry, surface, click on that and then click anywhere on the Grasshopper canvas. Right click on the node, set one surface, click on that. Now, next, what we want to do is to create a subdivision. You can do hexagonal subdivision or rectangular subdivision. It's entirely up to you. For this example, we are doing a hex grid. Double click on the canvas, type in 200. What that does is now it's increasing the subdivision. So if you think about this from a manufacturing perspective or from a fabrication perspective, we have 48 inches by 36. So if we double that, so 96 by 72, that will give us a point distance of about 1 inch. Okay. The outcome of this node is a set of curves and a set of points. Here you can see the X, Y, and Z dimensions. We will only be using points. Moving forward, let's bring in an image sampler. Connect the points to the image sampler. What that's doing is, let's go in, open an image, is you're trying to use the point location as an eyedropper and pick out information from the image. So first you need to match the dimension between the image and the surface. So the X and Y domain here, make sure it's the same dimension, right? They match 48 by 36. And here we're only picking out the color brightness. Check interpolate. Okay. And at this point, you can already try mapping using the point locations, right, to create variations of the circle. Right now, the values are coming straight from the image, and you can see the downside of this is, and the upper end of the value, the circles are too big. So we want to be able to keep the parametric relationship, but at the same time, be able to have more control over the values. So what we will do is do a remap number. We're trying to find the maximum and the minimum value of this list of number. In this case, we can see here is 0.05 to 0.988. we will use this as the source. So we're changing the lowest and the largest value of this set of numbers and remapping it to construct domain into something that we can control. So if we now use the remapped value, you can see as we change the slider, now it controls the upper bound of that value. Okay, it's the same thing as the lower bound value. So what this means is the smallest circles and the largest circle, the dimensions now controlled parametrically while maintaining the pattern that's coming from the image. So aesthetically, I want to invert this, like meaning the darkest area have the lowest value and the bright area have the larger value. And I want to invert that relationship. So what I want to do is bring in remap again, right? So the source will be from 0 to 1. The target will be from 1 to 0. Use that as the new value. So now you can see the number list inverted. Next set of issues that I want to address is, let's say, because we are fabricating this pattern on a digital cutter, and there are circles that are simply too small for the cutter. So I want to be able to control and let's say remove circles that are too small for the cutter. I don't really need to know exactly what that number is just yet, but in Grasshopper, I want to lay in a way for me to control that first. So in Math, under Math, click on Operator, larger than. Right, so what I'm looking at is evaluate the number list and compare it to this number. Only numbers that are larger than this number gets passed through, gets created. So the way to do it is when we look at the outcome, the output of this, it's a binary pattern. So we can use this node, call pattern, the list of number, call this list using that pattern. Do the same thing with points. And now, points, radius, hide this. So now I have a way to remove points that are too small. Okay. So this is the foundation of what we will be using for the rest of the first exercise. Please review this and let me know if you have any questions.